Hi guys, I thought I'd jump on here and go over question 11 from the homework questions of lesson 4E. It seems to be a bit of a harder question that people are getting stuck on. So the question is, a bridge is to be constructed over a river. The underside of the bridge has the shape of a parabola as seen in the picture. The river is 18 metres wide and the arch of the parabola must be anchored on the ground 3 metres back from the riverbanks. The bridge's arch must reach a maximum height of between 22 and 26 metres above the surface of the river. Find two different equations to represent the arches that satisfy the conditions. Then use technology to graph them on the same grid. Okay, so we're not going to graph, we're just going to go over how to get the equations. So let's look at the information that we are given. So we're told that the river is 18 metres wide and the bridge has to be anchored on the ground 3 metres back from the river. And we're also told that we have a height between 22 and 26 metres. Right. So right now we're working on vertex form of our equations, of our quadratic equations. So we can assume that we're going to be needing to use our vertex form. That is y equals a. All right. So looking back at our question, we know that our bridge is 18 metres wide plus 3 metres on either side. Okay, so if we imagine, let's have our graph here. Okay, so our x on our graph here is going to be our width of our bridge. So our width of our bridge, we're told, is 18 metres plus 3 metres on either side, because it has to be over the river. So that is equal to 24 metres. So I am going to say the middle of my bridge is going to be my y-axis. So I can say that on this side I have 12 metres of bridge, and on this side I have negative 12 metres of bridge. Alright, and our height is between 22 and 26 metres above the surface of the river. So I'm just going to say that my the height of my first equation for the bridge is going to be 22 metres. This here is our bridge. And our coordinate would be 0, 22. And then you could imagine that the river would run underneath, like so. So you know that's the river. And you can see that there would be 3 metres on either side. Okay, so now what we can do is we can use this information to put into our equation. Okay, so we found the vertex because we just said, because we know it's between 22 and 26 metres, I'm just saying that the height of my bridge at the moment is 22 metres. So I have a vertex here of 0, 22. So I can put that straight into my vertex equation here. Y equals a x minus 0 plus 22. Now I need one other point so I can find my a. So I'm just going to choose this point right here, which would be 12, 0. I'm going to put that into my equation so I can solve for a. Sorry, 12. And now I can solve for a. So bring my 22 to the other side. I get negative 22. 12 minus 0 is 0, so it's going to be 12, is 12, so it's going to be 12 squared. I'm going to work that out. And then I'm going to bring that to the other side. And I can simplify this. So A is equal to negative 11 over 72. So that means that my first equation is going to look like this. Y equals negative 11 over 72 x squared plus 22. So that is one of my equations. It asks us to find two. So let's go back. And this time, instead of my height being 22 meters, I'm going to change it to the maximum here, which is 26 meters. I change that to 26, so I change my vertex to 26. It'll be x minus 0 squared plus 26 this time. Again, I'll still use this as my point to put into the equation. So 0 equals a 12, 26. Move the 26 to the other side, so I get negative 26 equals a. I can square my 12, which is 144. Again, move my 144 to the other side, so I get negative 26 over 144 equals a. I can simplify that again to negative 13 over 72. And my second equation then is going to be negative 13 over 72 x squared plus 26. Now, you didn't just have to use 22 and 26. You could have also used the other numbers between 22 and 26 because we're not told what the number is. We're just told it's between 22 and 26. So we could have used 23, 24, or 25 and done the same method and came out with a different equation here.